So this is example 9.3, same book, and this is something I really want you to understand. Okay, this is a very useful example to understand how we actually design beam, how we actually analyze beam for the sake of design. Okay, because I hope you have started learning design of steel structures, and you will be able to understand that most of the times the load that you assume on the beams are UDL, okay, uniformly distributed load. So this is going to be a very good example to understand if I have a UDL on the beam and it's continuous beam, how the loads get distributed. See? How the loads get distributed. So let's see, it is a continuous beam. Subjected to a UDL. So each span is L, okay, and they're all equal, and all of them have the same moment of inertia. So it's a continuous beam and it's prismatic, okay, and the ends are not fixed; these are pinned or roller, okay. So we are going to solve this problem. What is required? We are going to find the reactions on this beam. So let's give the names A, B, C, and D. Okay, so this is the continuous beam, and we are required to determine the reactions. Okay, it is subjected to a simple UDL. Okay, so what is the degree of indeterminacy of this beam? Okay, total. It's, you could say there are 5 versus 3 equilibrium equations, 5 unknown versus 3 equilibrium equations, or you could say it is 4 versus 2. Okay, again it is a difference of 2. There are 2 excess unknowns, okay, beyond the number of equilibrium equations. So there are going to be 2 compatibility equations in order to find 2 redundants. So the first compatibility equation, so what if I ask you the value of displacement at B in the given beam? If there is no settlement, if this support is 100% rigid, it's not yielding, there is no settlement at B, so what is going to be the displacement at B in the given beam? 0. So we are actually going to find that delta 1, we are calling it delta 1. Delta 1 is what? Displacement along displacement measure 1 in the given beam. Okay, we're going to find that using principle of superposition. So delta 1 equal to, and again we are treating upward positive, delta 1 equal to delta 1 naught. Okay, so this is downward, but right now I'm writing the general value. When I put the value, I'll put it with a negative sign for this delta 1 naught because it is downward. Okay, but for now I'm writing a general expression. This vector is equal to this vector plus another vector plus another vector. Okay, plus delta 1 1 plus, oh, you need to be careful here. It's not delta 1 1 is the displacement at this location due to unit load at the same location. If you need to consider the full displacement due to the full value of RB, and how would you do that? You will say delta 1 1 times RB, okay, plus delta 1 2 times RC. This is due to the unit value of RC, so you will multiply it by RC. Clear? And since we know that this term is 0, so you can then proceed with, so you got one equation involving 2 unknowns. Okay, so this is at B, or should I say the first displacement measure. At C, we have again delta 2 equal to delta 2 naught plus delta 2 naught plus delta 2 1 times RB. Maybe we could stop calling them RB and RC. Maybe we could start saying it is better. Let me say, let's call this as this reaction as x1 and this as x2. Okay, let's switch over completely to the digits. Okay, so I would say this is x1 and this is x2. What? So we know what is x1 and x2. This is just a plus this displacement. Now what is this? Displacement at displacement along displacement measure 1 delta 1 1 due to a unit value of x1. Okay, and what is this? Displacement at this location due to a unit value of x2. So if you want to find the value of displacement over here due to full value of x2, you have to multiply it by x2. So what should I write next? Delta 2 1 x1 plus delta 2 2 x2. Okay, and delta 2 in our case it is 0. If there is settlement, you will take the actual value. Okay, so what is the strategy? So you got these equations. Okay, so you have got two equations, two unknowns. You need to find 6 displacements before you can come back to these equations, before you can start substituting the values. Okay, getting it? I want you to tell you something here. This term delta 1 1, sometimes we call this as flexibility, or sometimes flexibility coefficient. This is the coefficient of this equation. This is coefficient of x1, this is coefficient of x2 in this equation. Similarly, this is a coefficient for x1 and this is a coefficient for x2. And there is a nice matrix based way of writing this down. Okay, so we don't need to go that way for two equations, but if there are 100 equations, you better write them in terms of matrices, because computers are very good at solving matrices. Basically, we are good at programming the solution for matrices. Okay, so that's why the digits based symbol is better.